All right, we're going to spend 2 days on 6-7, and it says, we know that inverse operations undo each other. So, for example, when you were solving an equation, to undo addition, we would subtract. To undo multiplication, we would divide. We've also seen if you had a square root, we would square it. If we had a cube root, we would cube it. Likewise, if I had x squared, we would do the square root. So an inverse is going to undo the given function. So what I want you to write down up at the tippy top is when you want to find an inverse, what we do is we switch X and Y. And so I'm wearing my tool belt today because I like it, but I have a special tool. So I've got a light switch in here. And so it's just a visual to try to help you remember inverses switch the X and the Y. All right, one other thing I would like you to write down. The inverse of f of x, it's written like this. So go ahead and write this down. The inverse of f of x is f inverse of x. And that's the way we say it. We don't say f to the -1. It's in the spot of an exponent, but it's not, okay? That's just the inverse notation. All right, so in an inverse, you switch x and y. So we're going to look at two things today. We're going to look at ordered pairs, like where it's specific numbers, and we're going to look at equations. Tomorrow we'll take a look at some graphs, because there's really 3 ways to look at inverses. All right, Joshua, can you tell me, what is the definition for domain?
It's like the area from you can answer. That's correct.
Yes, okay. They're the numbers you can input, right? So they're the inputs. Sometimes we say they're the x values. So John, what's the definition of range? Yeah, actually it is. It's like how high it can go and how low it can go. Those are the possible y values, all right? So, in example 1, it said find the domain and range for f of x and f inverse of x, given the table of f of x. So Mia, if domain are the possible x values, in this table, what's the domain then? No, they're the x values in the table. So what are they? What are the x's in the table? -2, 1, and 4. So domain are the x values. In an equation, okay, and let me pause here a moment to make sure I can clarify this. Okay, do you know if I have a y equals mx plus b? That's a line that's slanted. And we talked about that the domain was all real numbers, or -infinity to infinity, because there's infinitely many points on that line, right? So the domain for a line, a slanted line, is -infinity to infinity. But in this table right here, these are 3 distinct points. It's not a line through these points. Nowhere does it say I have a line. These are just 3 points. So the domain are the listed x values. So Bennett, what's the range from this table? Joshua, you want to help him out?
Would it be the y values?
Yeah. So that's 0, 3, 5. So again, Joe, what's the definition of range?
The range would be the y values.
They're the y values that you can have or you do have, okay? So now, what I ask you underneath range is, let's write the table values as ordered pairs. So that's -2, 0, 1, 3, 4, 5. All right, and Meredith, can you remind us again, what's the definition of domain? The x values. Yeah, Joe?
With those values, like with the range, without that table, what would we put? Because like, usually we would put like infinity to -infinity.
Yeah, I'll explain that when we get to the equations, okay? Yeah, we'll get there. All right, I'm going to pause here because I forgot to put this on the homework. Is a function Okay, let's write a little definition. I forgot to put this in here. A function is when each x has exactly one y. So if I look at my f of x, this one is a function, okay? This one is a function because each x has only one y. Now, to do the inverse, what I had you write at the tippy top is that we switch the x and the y. So what we're going to do here, to the far right, we're going to take the table and we're going to switch the x and the y. So Amber, if domain are the x values, what is the domain of the inverse? Yes, it's 0, 3, and 5. Tynan, if range are the y values, what's my range in this table?
It would be -2, 1, and 4.
-2, 1, and 4. I want to pause a moment and I want you to notice something. The domain of f of x is the range of the inverse. The range of f of x is the domain of the inverse. They switch, okay? And I know it's silly. I want you to think of my light switch, that we're switching it. Let's write these as ordered pairs. It's 0, -2, 3, 1, and 5, 4. The inverse is also a function. We'll try to get to one that isn't. Notation. The inverse of f of x, and I already wrote this, it's f inverse of x, and that's the way we say it. Yeah.
What would this be used for in real life?
Well, what's going to happen is we're going to be in chapter 7 working with exponential functions. Remember those? You did those in Algebra 1 that look like this. Well, this year we're going to look at logarithms, and they are the inverse function of exponentials. In the real world, logarithms are used for the Richter scale. In chemistry, they're used for the pH scale. In music and auditory things, decibels are logarithmic scales. So those are just 3 quick ones that you're going to use inverses
Is
for.
that kind of like how, like, when you add volume to something, it's like if you have like 20 decibels,
Yeah.
you add another 20, it goes to like, instead of 40, it would be like.
Yeah, because and you'll see in chapter 7 when we hit logarithms. So like when they say an earthquake was like a 3.0 versus a 5 or a 6.0, it wasn't double, like it's like 10 to the third versus 10 to the 6th. Like it's really big. It's a lot stronger. Okay. If a relation and its inverse are functions, then they are called one-to-one. All right, so I'm going to give you 4 steps here. Step 1. Change. This is now I'm moving to equations. So in example 1, if you have an ordered pair, you just list the x values and list the y values. Now, in example 2 through 8, and that's as far as we're going to go today. Examples 2 through 8, we're going to deal with the equation, and then I'm going to circle back to your domain and range question, Joe. So, step 1, and step 1 is optional. It only if you are uncomfortable with f of x being the y. Step 2, we switch x and y. Step 3, solve for new y. And step 4, change new y to f inverse of x. So when you go to do your homework and as we continue to move through the chapter, I want you to, when you feel confused, go back to your notes. Okay, go back to your notes and reread them and say, what did we do? How did we do it? Yeah, Eli? Say that again. Ooh, great question. You could go back to the video. You guys, I'm recording these every day so that if you start to do the homework and you're like, I don't remember this, You could pull the video up. That'd be
Are you
outstanding.
recording right now?
Yeah.
Okay.
You're famous. All right, example 2. It says find f inverse of x if I have an equation, f of x equals the square root of 3x minus 2. So we're going to follow these 4 steps. Okay, f of x is another name for y. It's like Tim and Timmy. Okay, f of x is more formal. Y is a little bit more familiar. Step 2, switch the x and the y. Okay, step 2, switch. So think about my light switch I have here, my tool belt.
Would g of x also be y?
Y. Yes, great question. If we have g of x and h of x, you change them to y. So then, here's a beautiful connection to what we did in our chapter 6.5. Do you remember we solved square root equations? I need to square both sides in order to get rid of a square root, because step 3, solve for new y. So I'm going to get x squared equals 3y minus 2. And then I'm going to add 2 to both sides of this equation, and then divide by 3. I get x squared plus 2 over 3. Now, this y is, in fact, the inverse. So I'm going to rewrite it and tidy it up. So that's f inverse of x. All right, Joe, did you have a question?
Yeah. What would you be able to write it x of f? Like would that be the same thing as just having x?
No. The reason why we do f of x is we're saying it's a function in terms of x. So x of f wouldn't make sense. All right, let's try example 3. And I'm going to keep looking at the 4 steps until I have it down. F of x, step 1. That's just another name for y. So I'm going to make that y equals x plus 1, the quantity cubed. Step 2, switch the x and the y. All right, Peyton, because I know Eli hasn't been here. Peyton, what do I do to both sides of the equation that would undo a third power?
Cube root.
Awesome. Okay, we're going to undo that third power. So I'm going to do a cube root. So that's the cube root of x equals y plus 1, because the cube root of a quantity cube cancels. Now I just subtract 1. Notice, the minus 1 is not under the cube root, okay? So let me tidy this one up, and I'm going to replace the y with f inverse. That's step 4. So f inverse of x equals the cube root of x and then a minus 1. I'm going to guide you through example 4, then I'm going to pause, and I want you to do 5 through 8 on your own. Here we go. I'm going to change f of x to y, and on the right side, I'm going to go ahead and distribute. And I do want to mention something back on example 3. Do you notice I didn't take x plus 1 times x plus 1 times x plus 1? You don't want to do that when you have a quantity to a power by itself. Just do the root to both sides, okay? I don't want to expand it because that'll be horrible. All right, I'm going to switch x and y. And then step 3, solve for new y. So I add 4, and I'm going to divide by 2. A question I have for you, and we've asked and answered this probably a dozen times this year already. Can I cancel the 4 and the 2? Absolutely not. Those are terms in the numerator. You can only cancel common factors. So let me tidy this up and rename the new y. Okay, so this y is not the same as the first y. So you can't leave them the same letter. So I have to rewrite it as f inverse of x is x plus 4 over 2. You could, if you wanted to reduce it, you could make it 1/2 x plus 2. But do you see, I can't cancel the 2 and make it x plus 2, because x plus 2 is not the same as half of x plus 2. Alright, when you're ready, flip it over, and I'm going to give you a few minutes head start. Try example 5 through example 8. Do as many of them as you can. I'm going to work out example 5 just to see if we're going in the right direction. I switch the x and the y. I add the 8. To undo a third power, you're going to do a cube root. So f inverse of x, if you start to get comfortable, you can start skipping some steps. I'm getting f inverse of x is the cube root of x plus 8. Okay, that's an x squared minus 2. I know you can't see it real well. So I'm getting for number 6, f inverse of x is x squared minus 2. And again, if you start to get comfortable where I am, I know f of x is y, so I'm going to skip a step and say that's, 8y plus 1. Yeah.
On the test, would you want us to write f inverse of x equals whatever? Could we just write y?
You can't say y because this is y. Like, you've actually found the inverse. So you need to do that step 4 where you rename it.
Okay.
Because new y is the inverse. Alright, dividing by 8. So I'm going to rename this. F inverse of x is x minus 1 over 8. And, you know, if the function is named g of x, its inverse is g inverse of x. Like, you don't go name it f inverse. Alright, last one. I'm going to skip a step. And if you can go with me, do it. If not, go step 1. I'm going to switch x and y, subtracting 4. And then to undo a square root, you square. Well, that's f inverse. But do you remember x minus 4, the quantity squared, is x minus 4 times x minus 4? That's x squared minus 8x plus 16. it's not wrong to leave x minus 4 the quantity squared. That is certainly equivalent.